In this video, we'll be looking at a deeper analysis of the reduction method game we just looked at for 4 players, and really get into it and see why everyone's getting a fair share mathematically. So first, I want to just take a little mini exploration and see why are these players cutting exactly as much as we expect them to. So, for example, the very first round, we said that A cuts off this 4th piece, and we say that it's worth $2.50 to him. So why does he not cut off even more of the pizza, maybe something worth $8 to him, in the hopes that he'll get it in the end and get so much more pizza? Or why doesn't he cut off just a little bit of pizza in the hopes that somebody else will end up with that piece and there'll be a lot of pizza left for him in the next rounds? So we're going to look at why both of those are bad ideas. So let's just analyze the first move of A. So let's say if A instead cut too little. So instead he only cut this much. So he didn't cut something worth $2.50 to him. Let's just say he cut something worth $1 to him. What's the danger in that? Well, the danger in that is, let's say, B says, oh, that piece is way too little, I'll pass. C says, way too little, I'll pass. D says, way too little, I'll pass. Outcome, since A was the last one to own it, he gets it. So now he's stuck with this little tiny piece that's worth $1, and his strategy kind of backfired. So now, what about the other strategy? What if you cut too much? How can that backfire? So let's say A gets really greedy, and he cuts something worth $8. So let's say he cuts this whole 3/4 of the pizza worth $8 to him. So let's see how that can backfire. So now let's say B comes in and says, whoa, that's a really big piece of pizza. That's definitely worth more than $2.50 to me. So he's going to reduce it a little bit. So let's say he cuts it right here, and he takes this piece to play with for the remaining round. But let's say it just happens that this piece contains $7 of the $8 for A. So that piece is gone. A is never going to see that piece again. So if this piece is gone, then how much worth is left for him to play with in the remaining rounds? Well, if $7 are gone, then he only has $3 of worth to play with in the remaining rounds. And those $3 of worth, he has to compete against 2 other people for that. And that does not seem like very good odds, because he's probably going to be left with something worth less than $2.50. He might get something worth more than $2.50, but maybe not. And what's the even worst case scenario is, what if somehow this piece was worth $8 to A instead? Then he's only playing with, the only remaining portion that's left of the pizza is worth $2 for him. And in that case, it's impossible for him to get a fair share, because a fair share is $2.50. So he's going to always get something equal to or less than $2 in the remaining game. So we see that cutting too little, cutting too much is a bad idea, because you might not get a fair share in the end. So it turns out that cutting just right, as we'll see right now, will guarantee you a fair share in the end. So now let's analyze this game. So let's just go through and see what happens. So we're going to go through with each player and kind of analyze them in each round. So now A, he cut off a piece worth $2.50. We established that because cutting off too little or too much will be disastrous in the end. So he cut off a piece worth $2.50. This is worth $2.50 to him. B comes along and says, hey, I can cut this more. So he puts this piece, he puts this much back into the pizza. So now let's look at A. Since his initial piece was $2.50, the remaining pizza left here, this 3/4, was worth $7.50. And after this piece is put back, because B reduced it and he demanded this piece be put back, now the remaining pizza is worth the $7.50 plus whatever this is worth to A. So it's worth greater than or equal to $7.50. So this is good so far. So now, even though A is out of this round, the remaining pizza, so whatever's left to play with here, is going to be worth more than or equal to $7.50. Now let's look at B. Similar story. We have this piece right here, this blue piece, is worth $2.50 for B. But now C comes in and reduces it, so he demands that this much be put back. So since we had this much was worth $2.50 for B, so the remaining pizza was worth $7.50. So after this piece is put back, the remaining pizza is worth greater than or equal to $7.50, just like for A. Now let's look at for C. C has this piece, which is worth $2.50 to him. And let's look at D. So D passes, and the reason he passes is because this piece is not even worth $2.50 to him, which means that the remaining pizza is worth greater than or equal to $7.50 to him. And the reason for that is, since the remaining pizza is worth $7.50, that makes sense, because this piece that is the other piece of the pizza is worth less than $2.50 to him. So we see that for A, B, and D, who are going to be the people who are competing in round 2, the rest of the pizza is worth more than or equal to $7.50. And what about C? Well, C gets this slice, and how much was that worth to him? It was worth $2.50. So C is guaranteed he got a fair share. So, and this is all operating under the assumption that people are truthful, that they cut exactly 1/3 or 1/4 of the pizza. And they have to be, because if they don't do that, they might just mess themselves up in the end. So now let's analyze round 2. What's going on? So this remaining thing is worth greater than or equal to $7.50 for all the remaining competitors. We don't know exactly how much it's worth for everybody, but we know that it's at least $7.50 because of the calculations we did in round 1. So now what happens? A cuts off this big red piece, which is worth 1/3 of the pizza to him. So this is worth at least $2.50, because 1/3 of 7.5 is 2.5. So this is worth at least $2.50 to him. So that means that now what happens? So B comes in and he cuts it further, and he demands that this piece be put back. So now let's look at what is going through A's head. So since this big piece was worth at least $2.50 to him, then the remaining pizza was worth at least $5, because since in total it's 7.5, and he cut off a piece that was worth 1/3 of his total value of the pizza, so it was worth at least 2.5. But what does that also mean for the remaining pizza that he did not take? So what does that mean for this whole bottom half of the pizza? That means that that whole bottom half of the pizza for A is worth at least $5. And the reason for that is because since he cut off a piece that was worth 1/3, the remaining piece is 2/3. So 2/3 of at least 7.5 is at least 5. Okay, and now when this piece is put back into the pizza, it's worth even more. But we know that for A, the remaining pizza is worth greater than or equal to $5. Now what about B? He cut off this portion right here, this 1/4 of the pizza. So this is worth 1/3 of his total value of the pizza. So again, it's worth at least 2.5. But what does that mean for the remaining pizza? It's worth at least 2/3 of 7.5, which is $5. So the remaining pizza, which we see down here, is worth at least $5 to him. Okay, so let's write that in. At least $5. So now C is not playing. D does the reduction by 0% technique, and he gets the piece. So that means that the remaining piece of the pizza that's remaining for A and B is worth at least $5. And what about D? Well, D only did the reduction by 0% technique because he knew that this piece was worth at least $2.50 for him. So that's the important part of this game. People only take slices if it's worth at least a fair share to them. So D also gets a fair share. So it's worth at least 1/3 of the total value of the remaining pizza, and at least 1/3 of 7.5 is at least 2.5. So he also got at least 2.5. So now what happens? Now this is what's remaining, and it's important to note that for, remember, A and B, it's worth at least $5. So we see that in a 2-player divider selector game, of course, each person is going to get at least half the pizza. So if this pizza was worth exactly $5 for both of them, and keep in mind it's worth even more than that for both of them, even more or equal to. So in the base case where it's worth $5 for both of them, we just do divider selector, and we saw how divider selector results in each person getting at least $2.50. So we see that B in the end gets greater than or equal to $2.50 for his pizza, and so using the same method, A also gets greater than or equal to $2.50. So everybody gets a fair share. We see that C got exactly $2.50, and A, B, and D got greater than or equal to $2.50. And the reason we can do this, so if you just follow through the route again, it's because every time someone takes something out, they take something that's worth $2.50 or more. And what's left is worth enough so that in the following rounds, they will be able to get a fair share no matter how the pizza is divided. So getting a fair share depends on you being truthful, because if you're not truthful, then you will probably just mess it up for yourself, and something will go wrong and you won't get a fair share in the end. So this is kind of how this method works. You can see how you can apply this to N people and furthermore. So I think it's a really cool method because it's very algorithmic, and after every round somebody gets eliminated with their piece, and you just keep reducing the number of people more and more and more until you're done.